going to be talking about how you can use the new Strategus R package that's being developed to do network studies for prediction. So this is the new approach that we're taking, going away from developing individual study packages to actually just having a JSON specification and then using Strategus to actually execute that specification. So I'm going to be showing you how you can create the JSON spec for a prediction model for model development. There's also different modules that are available if you want to do model validation, which there will be videos coming for that. And also if you want to do other forms of analyses, there will be videos coming out for that. But for patient prediction, what you need to create a JSON spec for a network study is you need to have Strategus installed. You need to have patient prediction installed, and you need to have dplyr installed as well, because these are the free packages that are going to be used to create the JSON spec. So I'm just going to load these into my R environment, and then I need to extract the cohort. So the first thing you're going to do when you're creating a JSON spec is you need to have all the cohort definitions for your study inside that specification. So here I'm downloading 3 different cohort IDs from Atlas. So I'm using I guess you also need to have our OHDSI web API installed as well if you're going to be taking this route. So I'm actually using this authorized web API to have a connection to the web API that I actually have access to for Atlas. And then I'm using this our OHDSI web API's export cohort definition set. So you don't have to use this. You could manually create this cohort definition set, but it's much easier if you're using this web API function, because what you can do is you can put in the free IDs for your Atlas cohorts into this function. It's going to then download the JSON and the SQL for these cohorts, and that means I can then put that into my analysis spec. And that means if someone else is going to be running this study, all I have to do is share the JSON spec. They have all the cohorts that they need to run the study. So for this study, there's just 3 cohorts, but obviously if you were doing more models and you needed more cohorts, you'd put them all in here. If you're using predictors in your model as well as variables, from cohort, so cohort predictors in your model, then you would also want to put any of the cohort as predictors in here as well. So you could actually have quite a large list here. So I've got a key ring set up to set up my base URL so I don't share it with anyone. And then I also have that set up for my password and username. If you aren't using keyring, I do recommend using this. If you have it, some of the systems it's not always available on. So Linux, I know there can be issues, but I'm running this on a Mac and I don't have any issues. And I've also run this on Windows. So keyring's quite nice for just storing your personal, some private like passwords and such in an encrypted way. So if I run this, I'm now authorized. So I've connected to the base URLs for Atlas. So I've now authorized it using my username and password. And then I can run the next one that's going to now download these 3 cohorts into my R session. So you'll see here, it's saying it's fetching those 3 cohorts. So if I look at this cohort definitions now, it's basically going to be a data frame that has the JSON for the cohorts, the SQL for the cohorts. And if I click here, you're going to see those 3 IDs that I selected here. So now I have all my cohorts. For the Strategus JSON spec, you do have to change the format somewhat from this structure. So here I've just got a little function that is just changing this into a list from a data frame, and it's going to have cohort ID, cohort name, and cohort definition in there. So this is just what's the format's needed. And I can show you once I've demoed this where this code is coming from. There's actually a website online you can get this code, so you can get this function from online. You don't have to recreate this. Then the next thing is we do need to create a function called cohort shared resources. This takes a cohort definition set, or actually cohort definitions here, and it basically then creates a list with the cohort definition set to your input. And then it adds some class for that and then returns it. So this is just really just creating a list wrapper of your input here and adding some classes. So we're going to create this function because this is needed for Strategus. And that's our cohort extraction done and the function ready to insert into the JSON spec ready when we get to that point. So the next thing is pretty much every study you're going to do for a network study is going to be generating cohorts. So there is a module called cohort generator module, and the cohort generator module does exactly as it says. Is given the cohorts that you're going to add into your JSON spec, it's going to create all of those. So if we source this, it's basically taking some of the settings functions from the online GitHub. So if you went to the OHDSI repository cohort generator module, you'll see in the R folder there is a settings function.r, and you can actually see what's being sourced if you want to. But here what I'm going to do is I'm just going to do this, and now this is going to load up a function, and the function that's going to load up is this. So I'm basically extracting this by sourcing it. So now I have this function that has two inputs, incremental and generate stats. And this is the two inputs for the cohort generation. So incremental just means, do you want to remember what you've generated? So say you have 10 cohorts to generate, and you generate them. And then you realize that one of the cohorts actually you made a mistake and you need to modify it. If you downloaded the same 9 cohorts you already had and just changed the 10th one, if you're running in incremental mode, when you run cohort generator again, it's not going to recreate all the cohorts. It's going to see that 9 of them are still the same. It's just going to rerun and regenerate the one that's changed. So incremental is quite nice if you're still playing around and you're going to be potentially changing your cohorts, some of them but not all of them. So incremental is just that it will skip some time. It will skip past things that haven't changed. And then generate stats is just whether you want some statistics about your cohorts. So this just generates a few extra tables when you're generating your cohorts. So I'm just going to say true to these. It doesn't really affect too much to generate stats for prediction. The incremental could help if I'm having to change the cohorts. For example, say I develop a model, realize that I misspecified my target population or outcome cohort in some way. But not both of them, then incremental would be useful for me. So I'm going to run this. That's the cohort generation settings all done. So this is all you have to do. You source the cohort generator module, and then you basically just have these two inputs for your cohort generation settings. So the next thing for a prediction, once you've got your cohorts, once you've got your cohorts generated, is going to be then actually applying the prediction. So we're going to apply patient prediction at this point. But patient prediction takes in a list of model designs. That's what we saw. If you saw when the run multiple BLP example, we basically have to specify a set of model designs that are going to be developed. So for the prediction settings, that's what we're going to create. We're going to create a list of model designs, and a model design needs a covariate setting. So here I'm creating a covariate settings that says I want gender included, I want age groups. So this is age in 5-year buckets, binary variable, and here we're going to have condition groups. So I'm going to use the SNOMED hierarchy I'm going to use the error table, condition error table. I'm going to look back 1 year. I'm going to create a bunch of condition variables. They're again binary, and then we're going to use the drug group error as well. So we're going to use the drug error table. We're going to use the hierarchy for how you actually can group drugs together, and we're going to look back 1 year from index when we're creating these for each person. So here I've just got a nice set of features. These are the features that I often just start with when I do prediction. So I'm press enter here, and now I'm going to start a model design list. So here I'm just creating an empty list called model design, and I'm going to make sure it's length of 2. For this demo, I'm just going to show you how to write the JSON spec for 2 model designs, but there is no limit. You could actually have 200 here, and you could have some sort of way of creating those 200 designs however you want. So for the first entry into this list, so this list has two entries. So the first one, so for the first model design, I'm going to use patient health prediction, create model design. I'm going to pick one of the cohorts that I extracted as the target, one of the cohorts I extracted as the outcome. I'm going to do default restrict PLP settings. So basically I'm not sampling and I'm not restricting to any time periods or doing any restrictions. And then I'm going to create my study population. Here I'm removing people who had the outcome prior. So I'm predicting first time occurrence of the outcome. And you see here I'm removing people who had the prior anytime prior. Then I am requiring that they have a time at risk, but I'm only requiring them to have 1 day. So if they aren't observed for at least 1 day after index, they're going to be excluded. But other than that, they're eligible. And then finally, my prediction time at risk is 1 day after index to 3 years after index. So I'm predicting the outcome occurring basically 3 days after the target cohort start date. Covariate settings, I'm using the ones that we just showed. I'm not doing any feature engineering settings in this example. I'm not doing any sampling. I'm going to do default pre-processing that will normalize and remove redundant features and also remove features if they're less than 1 in 1,000 patients. Then I'm going to train a lasso regression, and I'm going to use default splitting. So I'm going to do 75 for training, 25 for testing, and I use threefold cross-validation for identifying the hyperparameters in the training data. And then I'm also going to run a covariate summary. So this just means that once I fit my model, I'm also going to do a bit of a descriptive study to see how the different groups, people with the outcome, without the outcome, in the train, in the test, and overall look. So let me just enter this, and this is created now. The first entry in our list has a model design entered. So now the next thing is defining and designing our next model design. So again, using the patient level prediction create model design function. I've actually changed the outcome here. So I had 6.7, I think, previously. Now I'm changing 6.8, using the same settings otherwise, but I'm also using a different model. So patient level prediction has a library of classifiers. Previously, I chose lasso regression. Now I'm doing gradient. So this time I'm doing random forest. So I can enter this in, and this is get my next model design. So now I have 2 model designs. I have all the cohorts that's needed. I will need to source the patient level prediction module, like we did for the cohort generator module. And this now is going to give me a prediction module setting. So I source this function. And this function, all it takes in as an input is a model design list. So this is just, it has to be a list. It has to contain model designs that use the patient level prediction create model design function. So if I enter this now, if I run this code, now I've got my prediction model specification all set up. So I've fully specified what models I want developed. I want 2 of them developed. I want a lasso, regression, a random forest, and I've changed the outcomes. So now the final thing to do is to create an empty analysis specification using this is from the Strategus library. Then I'm going to add the shared resources. So this is using that function that we created, the create cohort shared resources, and then I'm putting in my cohort definitions. So this is the cohorts that we downloaded, and then I created a list of these. So I'm adding the cohorts to the specification. Then I'm going to add in the cohort generator specifications. So this is add a module, which is the cohort generator, and there's the specs there. And then I add another module specifications, that is the patient level prediction model specifications. So here I'm basically just going to run this, and this is going to put everything together. So I've got my cohort definitions, I've got my cohort generator module specifications, and I've got my patient level prediction specifications. And if you look at this, effectively, this is just going to be a list, I believe. So you've got shared resources here, and in there, I think you'll see the cohort definitions. And then we also have the model specifications that I think the first one will be the cohort generator. And then the second one will be prediction. So this is just created a list, an R list that has all the information you need. And then finally, you can use the patient parallel loggers save settings to JSON function to save this R object as a JSON file. So if I enter this, it's now saved my settings. And if I go to the documents, this is what I just saved. You can see it's 1032. It's 1032 when it's saved. If I open this, this now is the JSON spec. So here we have the cohort ID, the cohort name, and the JSON for that cohort that can be rendered into SQL. We have the same for the second cohort, and then we have the same for the third cohort. And then we end up with our cohort generator specifications. So we've got the incremental and the generate stats. And then we have our prediction module, tells you the version. And then you have all the settings for the 2 designs here. So this is the 2 designs. One of them is going to be very large because we use a random forest. Actually has quite a lot of a large grid search for the hyperparameters. That's all specified here. So this is all the grid search that's being done for that random forest when you're fitting it. And then this actually is complete. So this is all we need now. You can share this with someone else. They can then load it in, and they can do really, it's a couple of lines to point this to their data, and they'll be able to run this study and develop the models exactly the same way as anyone else running this model. So you can share this, and you can get the model development done in a consistent way across as many data sets as you want across the OHDSI network. As long as they have their data mapped to CDM, it's very, very simple. So in the next video, I'm going to be showing actually how you can run this study from a JSON. So how you go from loading the JSON and actually running a study on your data. But again, it's actually very, very simple. I've actually got the code here. This is all that's needed. So it's a very small amount of code just to load and run it on your database.